Cool. It seems like everything is working properly. Probably, right? Test. We're probably fine. That's probably good. I'm playing some interesting music this time. Okay. I'm gonna play my own stream, and it might sound a little weird, but I want to see how it sounds. Okay. I'm gonna play my own stream. I'm playing some interesting music this time. Music's a little loud, frankly. I'm gonna turn the music down a tiny bit. Okay. Okay. I'm gonna play my own stream. Okay. Okay. Cool. Blinking. I think that means something is wrong, because I remember answering 3, like I remember answering with the link is operating normally, because I was thinking like, oh, like a flickering amber LED, like that means it's working properly. But blinking, I learned, sort of implies, at least in the context of this question, blinking implies a sort of, you know, consistency that wouldn't be replicated in the situation of a operational switch port. So I think it means, I think it's either one of these. STP could be, it could be an STP thing, but I think that would be weird. I'm gonna go for 1, but it could be 2. Okay. I answered that one while I was testing out the audio before this stream. The solution needs to support the transmission of multiple types of protocols and must be compatible with existing network infrastructure, which includes intermediate routers that only inspect outer packet headers for forwarding decisions. To connect multiple branch offices to the headquarters network, the solution needs to support the transmission of multiple. I'm gonna turn down the music. Wait, I'm gonna make sure the music is. It could be an S to connect multiple branch offices to the headquarters network. The solution needs to support the transmission of multiple. I'm gonna turn down the music. Let's see how this sounds. You are designing a VPN solution. You are designing a VPN solution to connect multiple branch offices to the headquarters network. The solution needs to support the transmission of multiple types of protocols. Okay, let's see if this is any better. Wait, I'm gonna make. You are designing a VPN solution to connect multiple branch offices to the headquarters network. The solution needs to support the transmission of multiple types of protocols. Okay, let's see if this is any better. Connect multiple branch offices to the headquarters network. The solution needs to support the transmission of multiple. I'm gonna turn down the music. I think we might be good. I think we might. There's no music audio right now because my headphones disconnected, but I know that they're gonna reconnect. There we go. Testing. The solution needs to support the transmission of multiple types of protocols and must be compatible with existing network infrastructure, which includes intermediate routers that only inspect outer packet headers for forwarding decisions. Generic routing encapsulation. I should probably do some research on this. Let me make sure I can open Obsidian right now. Yeah, no, see? I couldn't have. I'm so used to typing src like source. Awesome. Oh wow, and it's already, that's incredible. That's exciting. Okay, okay. GRE, is it worth checking out the RFC? Sure, I could do this. A number of different proposals currently exist for the encapsulation of one protocol over another protocol. Other types of encapsulations have been proposed for transporting IP over IP for policy purposes. This memo describes a protocol which is very similar to, but is more general than, the above proposals. In attempting to be more general, many protocol-specific nuances have been ignored. The result is that this proposal may be less suitable for a situation where a specific X over Y encapsulation has been described. It is the attempt of this protocol to provide a simple, general-purpose mechanism which reduces the problem of encapsulation from its current, O times... how do you articulate big O notation? From its current problem to a more manageable state. This proposal also attempts to provide a lightweight encapsulation for use in policy-based routing. This memo explicitly does not address the issue of when a packet should be encapsulated. This memo acknowledges but does not address problems with mutual encapsulation. In the most general case, a system that has a packet that needs to be encapsulated and routed. We call this the payload packet. The payload is first encapsulated in a GRE packet, which possibly also includes a route. The resulting GRE packet can then be encapsulated in some other protocol and then forwarded. We call this outer protocol the delivery protocol. The algorithms for processing this packet are discussed later. So there's the oh, that's my I gotta turn the laundry back on. Give me a sec. Sorry. Okay. Yeah, so there's sort of this dichotomy drawn between the payload. Wait, what? The payload is first encapsulated in a GRE packet, which possibly also includes a root. Maybe I need to keep reading. The entire encapsulated packet would then have the form delivery header, GRE header, payload packet. The packet GRE header has the form of, then, yeah. Okay, I don't think I need to learn the specifics of GRE. I just need to know it was about the two hold on, I'm scratching my leg. The GRE flags are encoded in the first two octets. Bit 0 is the most significant bit. Bit 15 is the least significant bits. Bits 13 through 15 are reserved for the version field. Bits 5 through 12 are reserved for future use and must be transmitted as 0. Sure. If the checksum present bit is set to 1, then the checksum field is present and contains valid info. If either the checksum present bit or the routing present bit are set, both the checksum and offset fields are present in the GRE packet. If the checksum parent bit is set to 1, the checksum field is present. If the checksum present bit or the routing present bit are set, both the checksum and offset fields are present in the GRE packet. Is this saying that if the checksum bit is set to 1, then both the checksum and offset fields are present? Okay, I see. If a routing present bit is set to 1, then it indicates the offset and routing fields are present and contain valid info. If either the checksum present bit or the routing present bit are set, both the oh, it's just saying the same thing as before. Okay. If the key present bit is set to 1, then it indicates that the key present field is present in the GRE header. Otherwise, the key field is not present in the GRE header. The sequence number present bit is set to 1, and it indicates that the sequence number field is present. Otherwise, the sequence number field is not present in the GRE header. The meaning of the strict source route bit is defined in other documents. I don't know what a strict source route is. Recursion control contains a 3-bit unsigned integer, which contains the number of additional encapsulations which are permissible. This should default to 0. The number version field must contain the value 0. Other values are outside the scope of this document. Okay. The protocol type field contains the protocol type of the payload packet. In general, the value will be the Ethernet protocol type field for the packet. Currently defined protocol types are listed below. Additional values may be defined in other documents. Offset. The offset field indicates the first octet offset from the start of the routing field to the first octet of the active source route entry to be examined. What? The offset field indicates the octet offset from the start of the routing field to the first octet of the active source route entry. I don't really know what this is saying, to be examined. This field is present if the routing preset, this field is present if the routing present, routing present or checksum present bit is set to, okay. This field is present. Present? Why is it, what do you mean present? Okay. If the routing okay. This field is present if the routing present, oh my god, why did I think it was saying present, like present and post-sent? Why would that ever be a phrase used? Okay, I'm going crazy. This field is present if the routing present or checksum present bit is set to 1 and contains valid information only if the routing present bit is set to 1. The checksum field contains the IP's checksum of the GRE header and the payload packet. This field is present if the routing present, if the routing present or checksum present bit is set to 1, and it contains valid information only if the checksum present bit is set to 1. The key field contains a 4-octet number which was inserted by the encapsulator and may be used by the receiver to authenticate the source of the packet. The techniques for determining authenticity are outside the scope of this document. The key field is only present if the key present field is set to 1. Okay. The sequence number field contains an unsigned 32-bit integer which is inserted by the encapsulator. It may be used by the receiver to establish the order in which packets have been transmitted from the encapsulator to the receiver. The exact algorithms for the generation of the sequence number and the semantics of their generation is outside the scope of this document. Okay, and this is the routing field as opposed to, yeah, so this is the GRE packet header. Okay, and then there's the optional routing field, and that's what this is. It's funny that this doesn't have a, do you see that? This doesn't have a wall. Dude. That's funny. Normally, a system which is forwarding delivery layer packets will not differentiate GRE packets from other packets in any way. However, a GRE packet may be received by a system. In this case, the system should use some delivery-specific means to determine that this is a GRE packet. Once this is determined, the key, sequence number, and checksum fields, if they contain valid information as indicated by the corresponding flags, may be checked. If the routing present bit is set to 1, then the address family field should be checked to determine the semantics and the use of the SRE length, SRE offset. What is SRE? Dude. But what is SRE? Am I stupid? Whoa, whoops. Oh, source route entry. Okay. Oh, and okay. Okay. Oh, this isn't even the existing structure. GRE enables the usage of protocols that are not normally supported by a network because the packets are wrapped within other packets that do not use supported protocols. To understand how this works, think about the difference between a car and a ferry. A car travels to roads on land while a ferry travels over water. A car cannot normally travel on water, however, a car can be loaded onto a ferry in order to do so. In this analogy, the type of terrain is like the network that supports certain routing protocols, and the vehicles are like data packets. A GRE is a way to load one type of packet within another type of packet so that the first packet can cross a network it would not normally cross, just as one type of vehicle, the car, is loaded onto another type of vehicle, the ferry, to cross terrain that other guys could not. For instance, suppose a company needs to set up a connection between the local area networks and their two different offices. Both LANs use the latest version of the Internet Protocol, IPv6, but in order to get from one office network to another, traffic must pass through a network managed by a third party, which is somewhat outdated and only supports IPv4. With GRE, the company could send traffic through this network by encapsulating IPv6 packets within IPv4 packets. Referring back to the analogy, IPv6 packets are the car, IPv4 packets are the ferry, and the third-party network is the water. All data sent over a network is broken up into smaller pieces called packets, and all packets have two parts, the payload and the header. The payload is the packet's actual contents, the data being sent. The header has information about where the packet comes from and what group of packets it belongs to. Each network protocol attaches a header to each packet. GRE attaches two headers to each packet. The GRE header, which is 4 bytes long, and an IP header, which is 20 bytes long. The GRE header indicates the protocol type used by the encapsulated packet. The IP header encapsulates the original packet's header and payload. This means that a GRE packet usually has two IP headers, one for the original packet, one added by the GRE protocol. Only the routers at each end of the GRE tunnel will reference the original non-GRE IP header. And what was the question? I'm going to go through this so I can see the question regarding GRE I got wrong, so then I can write down information regarding it. I think that's one. Isn't it not tools menu? Isn't it like, I could be wrong, I think it might be statistics menu, yeah. I just recently used Wireshark because I was, we were figuring out NDI, which is, it's like this camera thing. Yeah, network device interface. I was doing this NDI thing at work and I needed to use Wireshark to look at the, what's it called, Avahi? MDNS, to look for MDNS packets. Because this uses NDNS. Oh, I remember when this came out. Okay. Oh. I'm pretty sure it's yes, but I'm just making sure. What? That's crazy. Okay. I think this is correct then. Oh, I can link the internet. Oh, dude, what? Dude. Okay. um... $80 and 143 is a web server. 25 and 110, though, I'm not sure. I think I remember choosing web server and email server, but it ended up being not true. So I think I'm gonna go for web, DNS, and email. Really? It's web and email. Is it simple mail transport protocol? 25, port 110, post office protocol. I see. Okay. Both sides, I think no bonded channel was created. Oh, dude, I didn't even read the second one. Okay. That makes sense, because if a switch interface was designed for jumbo frames, it wouldn't be an issue if the host wasn't. Intermittent loss of connectivity. Well, I don't think it's 2. It's not 1. So really it's a question between crosstalk and excessive untwisting. And I don't think crosstalk would result in intermittent loss of connectivity, so I think I'm gonna go for 4. Yeah. Trivial file transfer protocol. I think it does operate over UDP. Isn't it 2? I remember getting that one wrong and it had really bothered me. That'd be APC, because it's the gold standard. Data locality. That one. Potential consequence of a rogue DHCP server. Oh, it's a stupid question. What problem can be mitigated? The filter, it, packet captures from the network. Trying to isolate email traffic. It's not 1. It's not 4. So it's either 2 or 3. I think 25. I remember 25 being a mail thing, so I'm gonna go for. What? TCP 143? What? Dude, am I thinking of 443? Oh, I'm an idiot. I'm always confusing 143 and 443. 443 is HTTPS, 143 is Internet Message Access Protocol. The Internet Mail... What is IMAP? Internet Message Access Protocol, okay, yeah. For being an email protocol, its name is very vague. His music is so good. I love Wolfgang Voigt. This guy's the GOAT for real. It's GHT. Oh, it's just GT? My bad. Yeah, this guy makes some awesome music. This guy's so talented. Does this really need 9 citations? This guy made the song that's playing right now. Man, I love the people of Germany. Much love to Germany. Network is designed with a backbone area. Open shortest path first. Okay. It's not one. Poison route. If that's like a network attack, I could imagine the answer being 2 would be advantageous. Okay. I could just be totally misunderstanding this. I might not even know what a poison root is. Okay. Allocated in a hierarchical manner. Wouldn't it be the first The next? I don't know what the next means. Because isn't the second part the network portion? Or isn't the second part the host portion? Actually, I kind of remember the number 45 pretty strongly. Is the answer the next 45 bits? Okay, that's crazy. Maybe because I'm gonna do something really stupid. Okay, maybe it's because the first 19 bits have something to do with like not that, and then the 45 has something to do with that, and then the next like 64 have to do with you know, the host portion of the protocol of the address. I cheated on that last one. One sec. I'm sorry, friends. I have to use the restroom. I'll be gone for a little bit. Hello all, I'm technically back, but I'm checking something really fast. Epic. Cool. I set up this script that automatically creates snapshots of this virtual machine I have on Proxmox, and it's working, confirmed now, which I'm happy about. I'm gonna turn the music down a tiny bit. Oh man. It's fine that I showed that, we're fine. Okay, cool. Alright. My phone's vibrating a lot. A small office with limited IT resources is looking to upgrade its network security to protect against basic external threats. The office network primarily handles simple web browsing and email communications. To keep it straightforward, it's a cost-effective solution that can be easily managed and maintained without requiring extensive security expertise. The primary goal is to block unauthorized external access while allowing legitimate internet use. I don't know, a packet filtering firewall? 54 operates at 2.4 gigahertz. It's not 1, it's not 2. Or, I mean, it's not 1, it's not 3. I knew it was 2. Whoops. What is used to connect a port on a patch panel to another network port? A RJ45 patch cord. Let me make sure that everything's at the right volume. I don't know, packet filtering firewall? 54 operates at 2.4 gigahertz. Okay, yeah. Everything's fine. We're fine. I actually might turn up the music a tiny bit. With questions like that, it's just always obviously a star topology. And that's precision time protocol. Wow, great transition. Thank you, Cider. That sucked. That was so. Oh my god. Oh my god. That was crazy. Root primary. Sorry. Conducting validation tests. Those are such stupid distractors. I don't even know what, like, you could really tell they were taking a vacation when CompTIA was making those distractor questions. That's so stupid. What distinguishes a collision domain from a broadcast domain? I think it does talk about physically shared media. Yeah. What was it? Root primary? $69, dude. An administrator needs to perform maintenance on routers and switches, authenticating them over TCP port 49. I don't know. I know that, I think, is it TACAX that uses TCP and then Radius that uses UDP? Or, no, because TACAX is newer, so I don't know why they would have such a low TCP port. I'm gonna go for Radius. Well, doesn't Radius use Kerberos? Wait, it might be TACAX. It might not even be Kerberos or TACAX. Or it might not even be Radius or TACAX. It could be like... I don't know. I'm gonna go for EAP. I could be wrong. It was TACAX. Okay. And that's because... well, it's just because TCP 449 is just like the TACAX. Yeah. Okay. My bad. It's not a traffic class. Wasn't it maximum throughput? that second to last question was also a case of like stupid distractor syndrome. Dumb distractor disease. What is the result of subnetting? Gigabit Ethernet? It's over. And a DMZ is sort of a silly marketing term. Because it implies, I mean, I got this from the questions, but it is true. It implies a sort of level of neutrality and shared ownership that isn't the case in that scenario. Do VLAN hopping attacks exploit? Can't ping any remote hosts? I don't really know what switch port configurations is referring to. I see. That's so crazy. That last question is so funny because I pretty strongly recall there being a question that talks about how you have like an office and how the office has thick like concrete walls and how you want to prioritize Wi-Fi speeds, but you also want to be able to have good connection throughout the entire office building. And so you think about it, and you think about the explicit mention of thick concrete walls, and you think to yourself, well, why would they mention that if they didn't want you to answer 2.4 gigahertz, right? Because 2.4 gigahertz has better solid surface penetration, right, when compared to 5 gigahertz. So you select 2.4, and then it's wrong. And so, you know, you ask Gemini or something, and it's like, well, it did say it wants faster data rates first. That is the first thing it said it wants, and presumably that's what it's prioritizing. And you think to yourself, okay, sure, I get it. You know, it's prioritizing faster data rates. The answer is really 5 gigahertz. I got it, okay? But then you have a question like that, and it's strange because it also mentions higher speeds first, I believe. And so, like, and it also talks about outdoor seating areas. It also talks about thick brick walls. And there, the answer really is 2.4 gigahertz. When, by the exact same logic as the answers to the last question, it could just as easily be 5 gigahertz if you want to prioritize speed, like what that question also said. So I don't really know. Like with questions like that, where it describes the physical, attributes of of where you're going to be setting up some sort of wireless networking technology, you could really argue any way for any answer, really. And so it's just irritating because it's not like there's nothing in the question that says what the answer should be, really, because anything that's arguable as the answer for one question is just as arguable for any other question, and it's just silly. Okay. Another stupid distractor question. Oh man, I wonder what this one's for. I wonder, dude. Maybe it's my fault for using CompTIA as distractor questions, or distractor answers. Like, I complain about them, but I did make, it's like that Subway meme, like people be like, Subway sucks so bad, but you made the sandwich, right? It's like, I complain these distractor answers are so bad, but I put them there. But the only reason I put them there is because they were CompTIA's answers, and I'm only using CompTIA's learning material. So, you know, it's kind of CompTIA's fault, really. I think a lot of it is all my fault. What? I think I remember getting this wrong before. It is customer premises equipment because it's within the premises, and while it is technically owned by the ISP, it's still the equipment of the customer, which is strange because it's on their property, which is strange. Windows server, the BIP config. Commonly used in Wi-Fi setups. I don't know. Like nowadays, mesh networks are pretty popular. I mean, you kind of would just use a tool like certbot, but I know what it's saying. These audit log questions are stupid. I have no idea what the answer to this would be. Okay. That was kind of a stupid distractor question too. Okay. Oh my god, I did the same thing again. God. Sorry everyone, I'm gonna go for like 10 minutes. Oh, yeah, not polished at an angle. Whoops. STP is a decreased priority, not an increased priority. Oh, what? Oh, I guess it makes, like, inbound to an Nginx server. Or an Nginx, sorry. The document. Okay, that makes sense. I was thinking a bridge because it said point to point, like it would bridge two network devices, but I guess a more real world situation would be something like a layer 2 switch. I don't know. Dude, I was planning on studying more, but I'm really, 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 really tired. I don't know why. I didn't sleep like too bad last night. So I'm probably